Today's lesson is called Distance in the Coordinate Plane using Pythagorean Theorem. How would you decide the distance between 2 points on the coordinate plane? So to think about this, you see a picture of the coordinate plane, and there are 4 points located on this coordinate plane. So you've got the coordinate, for example, -4, 7, where the puppy is located. You have the coordinate -4, -2, where the bone treat is located. You have the coordinate 5, 1, which is where the steak is located. And you have the coordinate 6, 7, which is where the dog house is located. So what I'd like you to do is pause this video and answer the 4 questions you see below. A, find the distance from the dog to the bone. B, find the distance from the dog to the house. C, find the distance from the dog to the steak. And D, which one is the most difficult to answer and why? So at this time, please pause the video and think about your responses, then resume the video to go over the answers. All right, now that you had a chance to try this, first, the distance from the dog to the bone, I drew in with a pink line. I was able to count those blocks because it is a vertical line, and I know it's going to take 9 units on the coordinate grid for the dog to get to the bone. The distance from the dog to the house, I drew in green. That is a completely horizontal line, so I can count the blocks and find out that it's going to take 10 units for the dog to get to the dog house. For C, the distance to the dog from the dog to the steak. That I could not count, so I wrote I can't answer. I'm not really sure how long that is. The best I would do is make some sort of guess, which leads us to question D. Which one is the most difficult to answer and why? It's the distance from the dog to the steak. And that's because out of all 3 of these distances, this is the only distance in orange that you see that was a diagonal line cutting across the coordinate plane in a way where we cannot count the blocks. If the line is vertical or horizontal, we can count them. So we're going to use that information to talk about how the Pythagorean theorem can help us find the distance between coordinates on the coordinate plane for these special situations where the lines are diagonal and we can't count the boxes. So it says the Pythagorean theorem can be extremely useful in the coordinate plane when we want to know the distance between 2 points or the length of a line segment. Finding the distance between points is helpful for various fields, such as navigation, computer graphics, and physics. GPS systems in cars and smartphones use mathematical formulas, including distance formula, to calculate the shortest route between points. How many of us are using our smartphones or GPS to get us from one location to another? So this is where it is used. So we're going to look at example 1 together. It says the 2 points A, 0, 6, which you see already plotted, and B, 8, 0, are on the coordinate grid already, connected with a straight line segment. So on the grid, we're going to draw a right triangle out of this diagonal line, because if we do that, we can have 2 sides that we can count, because one will be vertical and one will be horizontal, and we can use Pythagorean theorem to find the slanted side that we can't count. So I'm going to switch colors here. And I'm going to first trace from point A down straight vertically. That's going to be one of our legs. This leg is 1, 2, 3, 4, 5, 6 units in length. Then I'm going to go from that point and meet B to have our other leg, which is 1, 2, 3, 4, 5, 6, 7, 8 units long. Those 2 I can count. So because of that, I now have a right triangle, which means this diagonal distance we're trying to find is the hypotenuse. So I can use Pythagorean theorem, a squared plus b squared equals c squared, to find the length that I'm looking for from A to B. So it doesn't matter which leg is which. Typically, if the A is here, the side across from it is the A value. So I'm going to write A for 8, 8 for A, so 8 squared, plus 6 squared is the other leg. And then we don't know the hypotenuse. So 8 squared is 64. 6 squared is 36 equals C squared. 64 and 36 is going to make 100 equals C squared. I don't want C squared, I just want plain old C. So the opposite of squaring is taking the square root. Whatever I do to one side, I do to the other, and I see that C is 10. So that means the distance from A to B for this line segment is 10 units. So by drawing a right triangle out of the slanted or diagonal line, we're able to count 2 of the 3 sides of the triangle and use Pythagorean theorem to find the third side, which is always the distance we can't count, and it's a nice, easy way to calculate it. Let's look at another example together. The length of a line segment is also considered the distance between the 2 endpoints. This distance can always be found using the Pythagorean theorem, so we're going to look at another example. Again, this is if we have the coordinate grid in front of us. So this time we're going to do more than we did in the problem before. We're going to consider the points A, 3, 2 and B, 9, 6. So first we have A at 3, 2. We have B at 9, 6. Remember, always go over to the elevator before you go up or down. And we are going to connect these like so. That is the distance they're going to want us to find, and we cannot count it. All right, so we plotted those, and we connected with a line segment. We did part A. Now, on the grid, we want to draw that same right triangle. We just have to think about it a little bit more than we did before. So since we're not using the axes lines to help us, we want to take and draw from each point we know. So I'm going to go from A over to the right until I line up with the line that would be where B is. And then I'm going to go from B down so that they meet right there at that point and form this right triangle. Now, I'm able to count the horizontal line, which is the green line. It's 1, 2, 3, 4, 5, 6 units long. And I'm able to count the vertical line, which is the orange one, 1, 2, 3, 4. This one's 4 units long. And now I have the information I need to complete C, which is to determine the distance between A and B. So you can see that's the side opposite my right angle, the longest side, which is my hypotenuse. And this time, just to show you that the directions can always be changing and your answers might not always come out nicely, it's telling us we have to round to the nearest tenth. So let's see what they mean by getting our answer here. We're going to use Pythagorean theorem. One of our legs is 4. Our other leg is 6. And we don't know the hypotenuse. 4 squared is 16. 6 squared is 36. That equals C squared. 16 plus 36 makes 52. I don't want C squared, so I'll undo it by taking the square root. Whatever I do to one side, I do to the other. And when I do that on my calculator, square root of 52, I get 7.211025551, and so on, right? It just doesn't fit any more on my calculator. So you can tell that's currently an irrational number, right? Going to go on forever and never repeat. So that's why they want us to round this to the nearest tenth. So we'll take a look at the hundredths place. And since it's a 1, that's not enough to bump up my tenths place. So my final answer is going to be C is approximately 7.2. So that tells me that my distance from A to B is approximately 7.2 units. And that concludes our lesson on distance in the coordinate plane using Pythagorean theorem.